In this video, we are going to build a machine learning model to classify the wine quality, whether it is going to be a good or bad. In the current corporate world, companies want to bring lots of new products to the customers. So to help the wine industry companies, we are building a machine learning model to classify the wine quality based upon the quantities of the ingredients in it. Okay, let's decode the machine learning model. First, we have the wine dataset. In this dataset, we will be having the quantity of the chemicals present in the wine with respect to the taste of the wine. Okay, so once we have this dataset, we will be doing the analysis on the dataset, like exploring the data and how each ingredient quantity in wine is going to affect the wine taste, and drawing some charts and analyzing the impact of each ingredient in the wine taste. Once we are done with the dataset, we will be splitting the dataset into training dataset and test dataset. 80% of the dataset goes to the training dataset and 20% of the data goes to the test dataset. So once we are done with the dataset, we are going to create the model here. So the model which we are going to create here is a random forest classifier machine learning model, which is going to classify whether that particular wine taste is going to be good or bad. Okay, and once we create the random forest classifier machine learning model, we are going to train this model with the training dataset. So once our model is getting trained on the training dataset, we are going to evaluate our model performance with the test dataset. So once we are done with the evaluation of the model with the tested dataset, we are going to predict the values from the trained model. Okay, that's what we are going to do in this tutorial. Now let's jump into the coding. Here I have created a folder called wine quality. Here we have the wine quality red dataset. Okay, now let me open the Jupyter Lab. Sorry. So now our Jupyter Lab is up and running. Okay, before starting going into the coding, okay, now let's install the necessary Python libraries which are required for this tutorial. Okay, so we need to install the Python libraries which are required for this tutorial. So pip install, and matplotlib we need to draw the charts, and seaborn as well, and numpy and pandas for the dataset, and next one is we need the scikit-learn dataset, okay, for the models. So the Python libraries which we need for this tutorial is matplotlib library, seaborn, numpy, pandas, and scikit-learn. So if you press enter, these Python libraries will be installed in your system. I'm not going to install these Python libraries which I have already installed them in my system. Okay, so if you are running it for the first time, please do install these Python libraries first. Okay. So once we are done with the installation of the Python libraries, next step is we are going to import those Python libraries. Okay, first import numpy as np and import pandas as pd. Okay, these are the short forms for the numpy and pandas. So once we have imported the numpy and pandas, so we have to import the matplotlib Python library to draw the charts. Pyplot as plot. So this pyplot is the module which will be used in matplotlib to draw the charts. Okay, I have made a complete course on this matplotlib Python library in our channel. So if you are watching it for the first time, please go and watch it. You will be able to learn a lot of things what we can do with the matplotlib Python library. Okay, and next import seaborn as SNS. Okay, now from sklearn dot preprocessing model selection import try and test speed. Okay, and we need to import the model as well, right? From sklearn dot ensemble import random forest classifier. Okay, so these are the Python libraries which are required for this tutorial. Okay, and once we import them, so we have to read the dataset which is there here. Okay, wine quality red. Okay, here is the dataset which will be having the chemicals or the ingredients which are part of the wine preparation. Okay, now let's import this dataset, and wine data is equals to pd dot, which is from pandas pd, and read csv. Okay, I'm reading the csv file data. Right click, copying the path, and I'm going to paste it here. Okay, So execute it. Now let's see the top 5 rows from the wine dataset. Okay, so these are the top 5 rows from the wine dataset. Okay, and it is having the fixed acidity. It is one of the ingredient, and volatile acidity, and citric acid, and sugar content, and chlorides content, free sulfur dioxide, and total sulfur dioxide, and density of the wine, and pH level of the wine, and sulfates and alcohol quantity in the wine, and finally the quality. So we are going to define the we are going to predict the quality of the wine by considering all these columns. Okay, these are the columns which are part of the ingredients of the some of these products are ingredients of the wine. Okay, now we have the top 5 rows. Okay, now let's see how many number of record data set that we have. Okay, for that one, wine data shape we have to use. Shape gives us the number of rows in the data set with respect to the number of columns. So total we have the 12 columns. So one quality being part of the output column. So 11 columns that which we are going to use to predict the 12th column, which is the quality. And total we have the 1599 column. 1599 rows of data set we have. Okay, now let's check if there are any null values are there in the data set or not. Okay, null values check. How we are going to do is wine data dot is null. If you mention is null, it is going to give you another pandas data frame with the true and false. If it is the value is being false, in the sense this particular row, the row number first row in for the fixed STT is having a non-null value. Okay, if it is true means it will be having a null value. So we cannot be able to check all this each and every line manually, right? So for that one we have to use the add summation to this is null function. It is going to give us the columns on the left side, on the right side with the count if there are any column which is having the null values. Okay, so if you see here for all the columns it is giving 0, so that means we don't have any null values in the wine data set which we have. Okay, so our data set is good now. Okay, we are done with the null check. Now we have to do the duplicate check, duplicate records check, duplicate records check. Okay, we have to check if there are any duplicate records are there in the data set. Okay, for that one, wine data dot duplicated. You see here some of the values are coming as true, so it gives us the for each and every data set whether the particular row in the data set is a duplicated value or non-duplicated value. If it is true in the sense, it means it is having a duplicated value. If it is false in the sense, it is not having any duplicated value. Okay, so if you see here total 240 records we are having the duplicate records in our data set which are completely identical. Okay, so now we have to drop these 240 records because these duplicate records are going to influence the model performance, right? So we have to drop these duplicate records. So how we are going to do is wine data, we have a functionality called drop duplicates functionality in the pandas, so we are using it. Then in place is equals to 2. What exactly this in place does is, here we are removing the duplicates, right, from the wine data set, right? So this functionality, this duplicate removing functionality will applicable on the original data set directly. So that's what we are giving the in place is equals to true. Okay, let me execute it. Now we have identified 240 rows of the duplicated records. So earlier we have 1599, okay, close to 1600. If we remove 240, it will come around 1300. Okay, wine data dot shape. So as we predicted, so we have 1359 record data set now we have, which is now no duplicates, no null values. Our data set is completely clean. Let me print the data set now. Wine data. See here. So we have the 1359 rows with the 12 columns. Okay. Now we have the data. Now our data set is ready. So now next thing is we have to identify how this quality of the wine is going to be affected by the alcohol content, sulfates content, pH content, density content, total sulfuric acid. That's kind of the data analysis that we are going to do now. Okay, data analysis. We are going to do the data analysis now. Okay, first let's check what are the different values are there in the quality. Okay, for that one let me draw a chart. Plot dot figure of fixed size. We have imported this matplotlib module, right, pyplot module from the matplot library. So we are defining the size of that particular diagram. Okay, here x and y sizes in inches. So once that is done, sns dot category key what, and here we have x is equals to quality. We are going to draw for the quality, and data is equals to wine data, and kind is equals to count. Okay, so here it gives us the records. Okay, if you see here, we have the quality values ranging from 3 to 8. Okay, 3 to 8, these are the values ranging from the fine quality 3, 4, 5, 6, 7, 8. So 8 is being the maximum value and 3 is going to be the minimum value. So that is what we have with the wine quality. Okay, so we have the values ranging from value 3 to 8. Okay, now let's see for the remaining columns. What I'm going to do is wine data dot, I'm going to describe the data. Okay, as it is a numerical data, right, we are going to see the data. Okay, we are having the more number of columns. Okay, for that one, what I'm going to do is, what exactly this describe is going to give us the insights about the numerical data in the data set, insights about the numerical data. Okay, and let me transpose this one. Okay, transpose. Okay, now we have the columns on the left side and header is the count me. Okay, if you see here, we have the total 12 columns. Forget about the quality column. Okay, and fixed acidity. Okay, the mean value, standard value. So first one in the sense count, the number of records are having the data. So all are 1359, so no null values. And next one is the mean value of that particular column, and next one is the standard deviation, and third one is the fourth column is the minimum value of that in that particular column. Okay, 4.6 is the minimum value in the fixed acidity column. Okay, and this is the it is not at 25 percentage, it is at 25 percentile. Okay, and it is 50 percentile and it is 75 percentile, and next one is the maximum value for this particular column. Okay, now we have seen the drawn the chart for the categorical for the quality. So now we have to see that in a graphical representation view how this particular quality of the wine is going to be affected by with respect to the each and every ingredient or each and every column. Okay, for that one we are going to draw a chart. Okay, plot dot figure of fixed size is equals to 10 comma 10. Okay, and sns dot bar plot. Okay, which I am going to draw x is equals to quality, and here we are going to draw the subplots. Okay, for I comma column in enumerate of wine data dot columns. Okay, plot dot subplot of, don't worry guys, I'm going to explain you. Okay, okay, let me increase this size to 20. So what exactly we are doing is we are defining the size of this figure. Okay, 10 in the x-axis and that is the y-axis. Okay, and what we are doing is we are drawing the subplots. Okay, this wine dot data dot columns, it gives us the columns list of the columns in the data set. Total we have the 13 columns, right? So that's what. So what exactly is enumerated does is enumerate is going to give us the two records. One is the count of that particular thing and second one is the value for each and every column in the wine dot columns, that is what it gives us, the two values. Enumerate gives us the two values, one is the count and another one is the column name. Okay, and here we are drawing a subplot. Each and every time we are doing a subplot, right? So total we have 13 columns including the quality, 12 columns I guess, right? So yeah, we have the 12 columns. I guess 6 should be fine. Okay, 6 rows we are giving, and next one is the columns, number of columns, 2 columns, 2 charts for each and every row. Okay, 6 into 2, 12, and this is going to be the index of that particular column, 1 2 3 4 5 6 7 12, right? So that is going to be the index, and here we are drawing a bar plot in for the C bar, with x value, x-axis being the quality and y-axis being the particular column, each and every column which is repeating in the loop, and data is equals to wine data. Now let's have a look at it. Okay, if you see here, this is a fixed acidity, and this white black line is a blue line is says that the count, says about the quality, and this marker in the top says that, right, this lines, black lines, that is are going to be the content of that particular column value, fixed acidity contents. Okay, it is being ranging from the 7 to 9. Okay, and it is not going to give any good value for the fixed acidity for the quality. And if you see the volatile acidity here, this volatile acidity is high, that means the taste of the quality of the wine is being less. And if it is reduced to from 0. If it is 1, then the value is taste of the quantity is 3. But if it is ranging between 0.3 and 0.5, the quality of the wine is really good. So that means, so the volatile acidity should be less, so then the quality of the content will be, quality of the wine will be good. Okay, that's what we have observed from this picture. Okay, and when it coming to this particular graph, which is citric acid is low, I think that means the quality of the wine is also low. The citric acid value is higher than the value of the quality of the wine is also good. Okay, and residual sugar, if you see that it is same for all the fields, so we are not able to get anything much out of it with the residual sugar. And chlorides, if it is having higher values, the quality of the wine will be less, and if it is a less value, then the quality of the wine will be good. Okay, and it is inversely proportional. And free sulfur dioxide, I think we are not going to make anything much out of it, because it is similar for the lower taste value and higher quality values. Okay, and total sulfur dioxide also same, and we are not able to make much out of the density. Okay, and pH value also same, we are not going to make much out of the pH. And sulfates, I think, yeah, higher the sulfates values, the quality of the wine is also good. Okay, it is directly proportional. And alcohol, yeah, if alcohol quantity is high, then the quality of the wine is also high, and quality is the same column, so we can ignore it. So we are with these subplots, okay, bar plots, we came to know that some of the columns are directly proportional and some of the columns are inversely proportional. So as we have only having 12 columns, we can go through this like this. Okay, each and everything one, and we can make a note of it. But when we are having the huge number of columns in the real time, we cannot keep track of all these things, right? So we want all these graphs data into a single picture. So that's what we are going to do. That's the concept called the heat map. So heat map in the C-bar will give us this correlation matrix of this complete data set. Okay, let me write that. Okay, correlation is equals to wine data dot correlated. Okay, next SNS dot plot dot figure of fixed size 6,6 I'm going to give, and here I'm going to SNS dot heat map with this correlation. So this wine data correlation function gives us the correlation values each column with respect to the all the remaining 11 columns. So we have 12 columns, right? So column 1 with the correlation with the other columns, 11 columns including the self column, so total 12 columns. It will give us a matrix how that particular column is being proportional to the other column, whether it is directly proportional or whether it is a inverse proportional. Okay, that's what the data which we are going to with the CORR function, which we have taken into a correlation. Okay, which I am passing as a data set to the here. Okay, correlation, and annotation is equals to true and square is equals to true. Okay, and color bar is equals to true, and color map is equals to blues. Okay, and keys size equals to be 8. Okay, it looks cool. Okay, I think that's what it is. Let's draw this C bar. Okay, and yeah, so now let's understand what we have given. So heat map, this is a correlation, this is the relation between the columns in the data set. Okay, and annotation is equals to true, in the sense this is the column name, this annotation will be printed here. Okay, and square, I think we wanted a square shape, right? So that's the reason square is equals to true. And color bar, this color bar in the sense right side one is there, right? This is color bar should be visible, that's the reason true. And color map is equals to blues in the sense it is going to give us in the blue color, or you can give it to the any other color as well. And annotation key down, this size of this particular text inside this is there, right? This 0.26 and all that stuff, that is 8. We can increase this size and we can reduce that size. And I want to have the format. Okay, format is equals to 0.1f. Okay, yeah, if you see here it has been reduced to 1 decimal point, or we can have to 2 decimal points and 3 decimal points. Okay, here I'm going to have only 1 decimal point values. Okay, if you see here, first let's understand this color bar. It is being ranging from minus 0.6 to maximum value being the 1. Okay, if you see here, if it is a negative value minus 0.6, that means the color is almost similar to white. Okay, if it is reaching to the maximum value 1.0, that means it is going to be a full dark blue color. Okay, that means that, so the darker the color, the higher the correlation between those two columns. Okay, if it is the lighter, then that means it is inversely proportional actually. Okay, it is going to be inversely proportional to the column. Okay, so if you see here, this diagonal column is having a complete dark color, because this particular 1.0 is for the self column, fixed acidity 1%, 100% correlated with the fixed acidity. So same column values are correlated to the same column. So that's the reason whenever we are drawing any heat maps in the C bar, we have to ignore this diagonal column, because this diagonal column represents the self column correlation. So we have to ignore that. Okay, and if you see here, quality, for us we need the quality, right? So alcohol is 0.5 proportional. Okay, that means it is directly proportional to the quality of the wine. So higher the alcohol, then higher the quality of the wine. And next is the sulfates is also positive value 0.2. So higher the sulfates and higher the quality of the wine. And if you see the pH minus 0.1, I think it is negligible, inversely proportional. And density also minus 0.2, and total sulfur dioxide minus 0.2, minus 0.1. And residual sugar has no impact at all in the quality of the wine. Okay, if it is higher or the lower, it is not going to have any impact. But citric acid is going to have an impact directly proportional. If the higher the citric acid value, then higher the quality of the wine. Okay, same for the fixed acidity, higher the fixed acidity value, then higher the quality of the wine. So this is how we can get from the correlations heat map. Okay, now we have understood the find out the correlation between how these columns are going to impact the quality of the wine. Okay, now let me print the data set, wine data. Okay, here we have the data set. Now let's split this data set, input columns versus the output columns. Okay, input columns are going to be the wine data dot drop, except the quality column, remaining all goes to the input columns. Okay, and what is going to be the output data set is going to be the quality column, wine data dot okay. Now we have split the data set into input data set and output data set. Okay, now input will be having only 11 columns, and output will be having only one column, which is the wine quality. Okay, now wine quality we have, right? Output dot output of quality dot value counts. Okay, if you take the values quality spelling, okay, do this. Yeah, if you see here the quality 5 6 7 4 8 3. So if you see here 7 and 8 are the maximum values. Okay, so we are going to do, what we are going to do is, if the quality of the wine values which is equals to 7 or greater than 7, we are going to make it as a good. Okay, the wine quality is really good. And what are the values which are less than 7 5 6 3 4 are going to be bad colors. Okay, bad taste. So when the quality of the wine is greater than or equals to 7 and 8 7, then that means the quality of the wine is really good, otherwise it is bad. So that's what we are going to make the changes in the values. Okay, now output quality is equals to, yeah, output quality. Let me remove this one. What we are going to do is output is equals to what we have the column wine data of quality column here, right? So quality dot apply, what we are going to do is lambda function. Okay, x value is going to be 1 if x value greater than or equals to 7. Okay, else it is going to be a 0. Okay, now let me print the output dot value counts. It will be having only two values now, 1 and 0. See, 184. So 7 is 167 and plus 17, total 184 are having the good wine quality. And what are the values which are less than 7? 3 4 5 6, which are total 1175 values which are bad quality of the wine. Okay, now we have converted it into zeros and ones. Okay, now let me print the, we have the input data set and we have the output data set with the 0 and 1 values. Okay, now we have to split this data set into trained data set and tested data set. Okay, for that one we have to have the x train comma x test and y train comma y test. Okay, equals to, we have imported functionality train test split, right? That's what we are going to use. With input and output data sets are being given to the parameters and test size is equals to 0.2. So what exactly happens is, it is going to split this input data set and output data set into trained data set and tested data sets. With, when we are passing test size is equals to 0.2, that means 20% of the data set goes to the tested data set and 80% of the data goes to the trained data set. Okay, so that's what we have done. Or else we can print these values, x train dot shape, x test dot shape, y train dot shape and y test dot shape. Okay, so 1087 rows goes to the training data set and 272 rows goes to the tested data set. Okay, now we have split the data set into training data set and tested data set. Now what we have to do is, we have to prepare a model. Okay, we have to create the model now. Model creation. Okay, the model which we are going to create is random forest classifier. Okay, going to create the random forest classifier machine learning model. Okay, now we have to train the model, right? Model.fit, we have to train our model with the data set which is train data set. Okay, x underscore train comma x y underscore train, this is going to give us the train data set and our model is being trained now. Okay, our model has been trained. Now what we are doing is, once our model is trained, we have to evaluate our model with the test data set. So what we are going to do is, we have to predict the values for the test data set. Okay, and predicted values is equals to model dot predict of, what it is going to predict is the test data set. for the test data set, we are going to predict the values with the test data set, the predicted values from the model. Okay, let me print this prediction. So it will be having zeros and one, combination of zeros and ones. Okay, now we have this predicted values for the test data set from the model, and we have the actual values which are y test. Okay, here y test, which are having the original values, and these are the predicted values. How accurately our model is predicting the values, okay, when compared with the original values. For that one, we have to import the functionality from the sklearn, which is called the accuracy score. Okay, from sklearn dot metrics import accuracy score. Okay, I have imported the accuracy score. Now let's evaluate this accuracy score by passing the predicted values and along with the original values, which is predicted and y underscore test. So PRAD in the sense which is the predicted values from the model for the test data set and actual values from the test data set. Okay, usually this value ranges from 0 to 1. If the value is nearest to the 1, that means our model is performing really well. If it is near to 0, and our model is not performing well in the sense. Okay, so as it is being 0.88, so that means 88% is close to 88% is right. So 88% is our model has been predicted the correct values. Okay, so I think usually in real world, I think 88% is a really good number. So we can say that our model is really working, predicting the values really work fine. I think in real world, I think achieving this 88 number is really a challenging one, but I think our model is predicting the values properly and our model is working really fine. Okay, so now we have evaluated our model and I'm satisfied with our model results. Now what we are going to do is we are going to predict the values. Okay, predict the values for the our model, how it is going to predict the values in the real time. Okay, and let me open the data set. Here we have the data set wine quality rate. Let me close these ones. Let me open in the notepad. If you see in the notepad, and we have the comma separated values, right? Let's pick one of the column. Here the wine test is 7, that means it should look, it should give us the value as 1. Okay, coming here. Okay, input is equals to this values, and input shape is equals to np dot array of input and that reshape of 1 comma minus 1. The reason why we are reshaping is we are taking the values and we are passing it to and creating a numpy array, and why we are reshaping is our model has been predicting, expecting the values in multiple values, but we have only one value to predict. So that's the reason we are reshaping the numpy array. Okay, now model dot predict of input shape. Okay, see it is giving one value in the sense that means our model is predicting the this particular wine test is going to be really good for this particular record. Okay, now let's check for the other one. Let's check for this one. It is 5, right? I think it should come as 0. Okay, let me pass it here. Yeah, it's giving 0. That means the wine taste is not going to be really good. And what we can do is, let me create a function, define predict function, model name comma input dataset. Okay, for predicting, giving that values, it has to do these things. Result is equals to, okay, and if result of 0 is going to be 1, that means return wine quality is going to be good. Okay, if result 0 is going to be 0, that means return wine quality is going to be bad. Okay, we have created a function. Now let's predict the values. Predict, here instead of model it should be model name. Okay, predict, and let's pass these numbers. Wine quality is going to be bad. Okay. Now let's check for the other value. This is also going to be negative. Testing. Okay. Should give us the wine quality is going to be bad. Yeah, it's giving wine quality is going to be bad. And let me take one which is 7 or 8. For this one it says the wine quality is going to be good. Yeah, so this is what wine quality is going to be good. Let's check for the other one. Yeah, for it is, this is 8. This last column is quality. Okay, quality rating, so that's the reason I'm excluding it, because it is going to be the output column. Okay, remaining columns, 11 columns are going to be the input columns. Okay, so it says wine quality is going to be good. Okay, this is how our model is going to predict based upon the quantity of the ingredients and in the wine. It is going to predict whether the wine quality is going to be good or wine quality is going to be bad. Okay, let's recap what we have done so far. Okay, we have imported the necessary Python libraries, which is NumPy and Pandas for the data handling and arrays, and Matplotlib and Seaborn for the to draw the charts. And we have imported the train test split to split the dataset into train dataset and test dataset. And we have imported the random forest classifier machine learning model, okay, algorithm for the model creation. And here we read the data from the dataset, okay, wine data. And here we had printed the top 5 rows from the dataset, okay, which is having the total 12 columns, and fixed acidity, volatile acidity, citric acid, residual sugar, chloride, sulfur dioxide, total sulfur dioxide, density, pH, sulfates. All these are being going to be the input columns, and quality is going to be the output column. Okay, total we have 1599 rows of data, and with the 12 columns. Okay, and here we have done the null check. We don't have any null values in our data set. And here we had checked for the duplicate check, so we came to know that 240 records are having the duplicate records, so we had removed those duplicate records. After that, our count has been reduced to 1359 from 1599. Okay, so we are left with the 1359 records data set. Okay, this is the final data set. So once we have this data set, we have done the data analysis on this data set by drawing some charts. So one of the chart is categorical plot on the quality of the wine. Okay, it is ranging from 3 to 8. Okay, and I could see that most number of records are for the where the quality is 5, 6, and 7, 8 are less. Okay, fine, but 3 and 4 are okay. Okay, count twice. And here we have done the describe of the numerical data in the dataset. So all the columns are numerical dataset. So we have got the 12 columns, and these 12 columns data insights from the with the help of the describe function. So here we get to know the count, mean, standard deviation, minimum value, 25 percentile, 50 percentile, 75 percentile, and maximum value from the for each and every column. Okay, and finally here we have drawn the subplots for each and every column against the quality, how it is going to affect the quality of the wine by the presence of this particular column. Okay, and see, we have observed that some of the columns like volatile acidities will be having the inversely proportional to the quality of the wine, and citric acid is going to be the directly proportional, because higher the citric acid value, the higher the quality of the wine. And if the volatile acidity lower, the higher the value of the volatile acidity, and lower the value of the quality. Okay, and similar to the chlorides, it is inversely proportional, higher the value of the chlorides and lower the quality of the wine. And yeah, similarly sulfates is directly proportional, so higher the sulfates value and higher the quality of the wine. Okay, and here we have drawn some correlation matrix. Okay, how that columns are in the data set are correlated with each other. So we are mostly interested in the quality column, how these other 11 columns are correlated with the quality. Okay, I think all sulfates and citric acid and fixed acidity are directly proportional to the quality of the wine, and remaining all are, I think, residual sugar has zero impact in the quality of the wine, and but volatile was acidity and chlorides, free sulfur dioxide and total sulfur dioxide density and pH are negative correlated to the quality. So if the higher these values of these columns, and becomes the lower the quality of the wine. Okay, so that's what. And finally we had this wine data set, and we had to split the data set into input data set and output data set. So output column is going to be the quality, and remaining 11 columns are going to be the input columns. Okay, and once we spread the input and output data set, so we have got the values taste of the wine ranging from rating to 3 to 8. So what we have done is, whatever the value of the wine quality is greater than or equals to 7, then we have made it as a 1. That means the wine taste is really good, and if it is less than 7, that means that the wine taste is going to be bad. Okay, that's what we have done. Okay, we have converted this 3 to 8 rating to zeros and ones. Okay, and 0 means the wine quality is going to be bad, and 1 is that wine quality is really good. Okay, and once we have done that, we have split the data set into training data set and tested data set. 80% of the data goes to the training data set, and 20% of the data set goes to the tested data set. Okay, so 1087 rows are going to be the training data set, and 270 rows are going to be the tested data set. And here we have finally created a random forest classifier machine learning model. Okay, this random forest classifier model is going to classify the whether that wine test is going to be good or bad based upon the certain values. Okay, and here we have trained the model with the training data set. Okay, and once our model is trained, and we have evaluated our model performance with the by predicting the values for the test data set. Okay, and here are the predicted values for the test data set, and here we are also having the original values for the test data set in the y test, right? So here we have imported the accuracy score to compare how accurately our model is predicting the values. Okay, when it is compared with the original values. So that's what accuracy score does. So we have passed the two parameters. One of the parameters is the predicted values from the model for the tested data set, and another one is the original values for the tested data set. So when we compare the when we calculated the accuracy score, it is came around 88, 0.88. So 88% of times our model is predicting the proper higher correct values. Okay, and here is the input data set. So once our model is really performing really well, then we started predicting the values within the real time. Okay, we have created a function called predict function by taking the model name and input array as the data set, and here we are calculating the predicting the values in the real time. So here this is the function. When we call this function, it is going to predict the wine quality is going to be good or bad. Okay, that's it, the tutorial, guys, on to predict the wine quality with the random forest classifier machine learning model. Okay, and if you like the content in this video, please do like and subscribe to our channel. Thank you. Thanks for watching this video.